So today we're going to talk about finding the equation of the tangent line to the function at a given point. Okay, so the first thing you want to do to find the equation of a line in general, right, is we need to find a slope and a point. Okay, so those are the two things you need, right? So this is throwing it back to algebra. Okay, so I'm going to just first try to find the slope by saying that the slope of the tangent line, which I'm going to just denote as m tan, at x equals 1 is equal to the derivative at 1. Right, so over in the corner, I'm just going to remind you, right, the slope of the tangent line to the graph of f at x equals 1 is the derivative at 1. Okay, so they're equivalent. And then the other thing to just remind you of is I denote the slope of the tangent line as m tan, right? So you remember back from algebra that m was the slope. So that's where my notation m tan comes from. The below it I write tan for abbreviation for tangent line. So slope of the tangent line. Okay. And then also I need a point, right? So I need a point on the graph, which the only point that I know how to find here where it makes sense, where it's on both the function and on the tangent line, is at x equals 1, right? So way back before I did show you like kind of just a rough sketch here, just making up that this is the function f, and then here is my point and the tangent line to the graph, right, through that point, and this is at x equals 1, right? So this is my tangent line. Okay, so remember the tangent line only goes through one point on the graph of f, and in this case, since it said at x equals 1, I know the tangent line's going through that point at x equals 1, right? So in other words, I know that the point on my tangent line is 1 comma and then f of 1. Okay, so remember that to find the corresponding y value for both the function and the tangent line, so in other words to find this coordinate, it's just going to be 1 comma f of 1. Okay, so if I plug in 1 into the function, I will get the y value at that point highlighted in purple for both the tangent line and the function. Okay, so now I can easily find the point, right? Because it's 1 comma f of 1, and to find f of 1, I just plug that into the function. I plug 1 into the function, so f of 1 is equal to 2, 1 squared plus 3 times 1, and so this is equal to 5. So my point is 1 comma 5. Okay, now the calculus, right? The calculus is I need to find the derivative at 1. So first, before I find the derivative at 1, I just need to find the derivative of the function. So f prime of x is equal to. And so now notice that this is a sum of functions, right? So I'm going to say it's the derivative of the first plus the derivative of the second. And so now I recognize that 2 times x squared, that's a constant or a number times the function. So I copy the number times the derivative of the function, and then plus the derivative of a number times my variable, number times x is just 3. Okay, so then here this becomes 2, and then using power rule to take the derivative of x squared, I get 2x plus 3. So this is equal to 4x plus 3. Okay, so I found the derivative function. Now to just find the derivative at 1, in other words f prime, I'm just going to plug in 1 into my derivative function, right? So I'm just going to have 4 times 1 plus 3, which is 7. Okay, so just like you know how to find f of 1, you plug in 1 into the function f, right? Same thing for f prime of 1, you plug in 1 into the derivative function. Okay, so now I have all my pieces, right? I have what the slope is of the tangent line. The slope is 7, and I have the point on the tangent line, which is 1 comma 5. So I'm going to highlight these just so you can see. So I have my main points here. I have a point and I have the slope to find the equation of the tangent line. So now what we're going to use is point slope form. Okay, so this is y minus y1 is equal to mx minus x1. Okay, and so this is why I was saying for calculus this is an important form, because in this case it will take us a lot longer to go about finding the b value or the y-intercept in the y equals mx plus b form, whereas if we just use this form we can just plug in the values and we're done with the question. Okay, so here I'm just going to plug in, this is my x1 and this is my y1, and then like I said 7 is my m. So this is just going to be y minus 5 is equal to 7 times x minus 1. And then that would be our answer here. Okay, so if it does for some reason give you the form on a multiple choice question on the AP exam in y equals mx plus b form, you can still change from point slope form to y-intercept form. Okay, so all you would have to do is just distribute the 7. So you would get y minus 5 is equal to 7x minus 1. And then you would just add over the 5, right, to both sides of the equation. So you would get y is equal to 7x plus 4. Okay, so that's the alternative. Alright, but see how much faster it was, right, to just use point slope form. And then if you needed it to be in y-intercept form, to just go that route, versus trying to plug in the 1 and the 5, solve for the b value, and then have the equation. All right, because it is possible that this would be an open response question where it asks you for the tangent line, and so you wouldn't need it to be in y equals mx plus b form. You could just need to write it using one of the equations that's correct. So there's 3 different forms for writing a line, but this one's the easiest one, is point slope form.